Most of what your brain knows comes from one trick, noticing what's the same and what's different. Let's play a quick game of odd one out. Which one doesn't belong? Again, which one feels off? At any point did your brain just go, I don't know exactly what that is, but I know it's not like the rest? That feeling is a basic idea behind a technique in AI called contrastive learning. Instead of telling a model what every single thing is, for example, this is a dog, this is a cat, we teach it which things belong together and which ones don't. Think of contrastive learning as building a map of relationships, where distance measures how closely things are related. The model turns each image into a vector, a list of numbers, so it becomes a point in an abstract embedding space where the model stores its internal understanding of the images. If two images are similar in meaning, we want their dots close. If they're different, we want them far apart. We train the model with small groups of three images, an anchor, a positive, and a negative image. For the anchor, we make two pairs, anchor positive and anchor negative, and label them accordingly. We never have to say this is a cat or this is a dog, just these two go together, these two don't. During training, the model gets a loss, a penalty score that goes up if positives are too far apart or negatives are too close. To shrink that loss, it keeps adjusting its parameters. Over many updates, the space self-organizes. Similar images cluster, unrelated ones separate, and the model ends up with a geometric understanding of the data. Now that sounds pretty abstract, but you've seen it in real life. Say you're listening to music. You play song A all the way through and hit repeat. You add song B to your late night playlist. You skip song C after 8 seconds. From that alone, Spotify infers that A and B are good matches for your taste right now, and C isn't. Your behavior is the data. Now it turns that behavior into contrastive pairs. Take song A as an anchor. AB is a positive pair, AC is a negative pair. The same rule applies as before. Pull positives closer to A in song space, push negatives away. Across millions of users, Spotify learns a huge audio plus taste map and where your taste lands in it. To make a made-for-you playlist, Spotify grabs a few songs you clearly love and looks for nearby points in that space. It filters out tracks you're sick of or recently skipped, and what's left becomes a playlist that fits your taste so well it feels scary. What's wild is that this isn't just how machines learn, it's also how we learn. In cognitive psychology, studies with infants and children show that simply comparing examples helps them form categories faster than seeing each example by itself. So when your brain plays odd one out with zebras and fake zebras, or when a model clusters images in an embedding space, they're both learning by contrast. Intelligence, whether it's yours or an AI's, often starts with one question. Which one of these things is different from the rest?